this one here, notice that the x-axis is scaled in terms of just like 1, 2, 3, and it's not in terms of pi. But we really do the same thing. Okay, so what parts do we need? We still need A, the amplitude, P, the vertical middle. We need the period to calculate B, and we also need the horizontal shift. So that's what I'm going to do. I'm just going to start with my amplitude. My amplitude, I'm going to subtract. Okay, we know it goes from 4 to -2. The amplitude is going to be 6 divided by 2 is 3. We know that the vertical middle is going to be halfway between those two y coordinates. So halfway between 4 and -2 is going to be 1. It's going to go from 1 up 3 to 4, down 3 to -2. Okay, our period, same thing. We still need to find the difference between the x coordinates. That gives me a distance. It's going to be 8 units from -3 to +5. Okay, since that's a min and max, that's going to be only half the period, so I want to double that. So my period works out to be 16 units. My b now, when I calculate b, notice that the pi's don't cancel out this time. Now I can simplify this to pi over 8, and there's nothing wrong with that, but I'm going to leave it like that because the nice thing about this form, we'll see later on, is that this form actually shows me that the actual period shows up in the equation. So this is nice. So when we look at the equation in this form, the 2 pi divided by form, we actually can see the period. So in this case, we haven't calculated. I've yet to do, oops, how do I erase it? There we go. I still need to find my horizontal shift. Well, let's just use cosine. So for our P, sorry, that's Q here. That's Q, and this is my P for cosine. I'm just going to put cos in the brackets here. It's going to be at the max value. So P value is going to be -3. Now I can write in my equation my amplitude of 3 cosine my period, my B value is 2 pi over the period. Now I can actually see the period in the function now. My period is 16 plus 3. Okay, so P is equal to -3, so we'll go plus -3, and then the vertical shift of +1. So there it is. So this is a function where the pi's don't cancel out, and so we end up with pi in our B value, which indicates that I've actually scaled my axis in terms of just like numbers without pi. Okay, so the last one here, we want to determine the equation of the function. So again, we want to do the same thing. We want to find out the amplitude, the distance from the middle to the top. Okay, we can see it's 2. Okay, the amplitude is going to be 5 minus 3 divided by 2. 5 minus 1, that's the min, divided by 2, which is 2. Our middle is going to be at 3, so 5 plus 1 over 2 is 3. My period, I can see from the graph, just looking from here to here, my period, and now I'm not going from min to max, I'm going to min. So that's my actual period. My period is pi. That makes my B value equal to horizontal compression of 2. Okay, so there's my B value. And then the equation for the function, we just need to locate the coordinate of the max point. I'm going to use that. I could use the min point, I suppose, and use a negative cosine graph. Maybe we'll do that. We'll just change it up a bit. Or we can use that coordinate here of 7 pi over 12. Oh, actually, that's not 7 pi over 12, is it? That coordinate is going to be pi over 2. Okay, it's going to be halfway in between. But I'm actually going to use a negative cosine graph and just say the shift is 0. So I'm just going to say negative cosine. My B value is 2. I'm going to use a shift of 0. and that would be perfectly fine. If I were to use this point here, okay, then it could be written like this. 2 cosine, I'm not going to use a negative cosine graph in this case, and then I can use a shift of pi over 2. Okay, so that would be using this red coordinate here. The black would be using the other coordinate there. So that goes with that, and this one goes with that. Okay. The last thing is, it says find, if this is my position, 7 pi over 12, 4.73. How do I get to this position here? Well, to find the x position of that coordinate, really that is, we can use some symmetry. Okay, that's not quite a full period because a full period would be over here. Okay, that doesn't quite work. But notice that the distance from here to here, from the max backwards and the max, or max forwards and the max backwards, those distances are the same. Okay, so if I know what the position of this is, okay, that's going to be halfway between here. So it's going to be 9 pi over 6, which is 3 pi over 2. Okay, when I work that out, I know that from here to here represents a distance. Okay, so if I want to find that distance, I'm going to start at 7 pi over 12, and I'm going to subtract, and I'm going to end up with 7 pi over 12 minus pi over 2 is going to be 1 pi over 12 positive, okay, because that's going to be actually a vector that is going to go in this direction because I did end minus start. So if I want to get to that blue dot there, I just go backwards the same amount. So this position here is going to be found by starting at 3 pi over 2, okay, and I'm going to go backwards. Okay, so this minus is actually going backwards. Okay, it's going backwards that same amount. So that's going to be, what is that, 18 pi over 12 minus 1 pi over 12 is going to be 17 pi over 12. So that position, again, notice that I'm using all sorts of symmetry here. Okay, anytime I can find symmetry, I'm going to be able to use that. So I've used this symmetry from outside. I could have used the symmetry, I'll do this in a different color. I could have done it from the middle as well. Okay, I could have gone this way and this way. Okay, that distance from here to here is going to be pi minus 7 pi over 12. That's going to be 5 pi over 12. So if I want to get to there, I'll go pi over 12, or 12 pi over 12 plus 5 pi over 12, which gives me again the 17 pi over 12, which I calculated differently. Okay, so there's all sorts of ways to do it. You don't have to stick with one, but the key is, can you use symmetry to find those points? And those happen to be theta 1 and theta 2 points.